Okay. And all right, so you're standing on a train station platform as a train goes by close to you. So we got a dude, and we got a train flying by here, which is just gonna look like this. And it has a whistle. And I'm gonna draw something to make it more wheelie. All right, there we go. Okay. So as the train approaches, we've got a frequency of 92 hertz. So train approaches. And we've got another frequency as the train recedes. And then we've got a speed of sound of 340 meters per second. So it wants us to find the value of the actual train frequency. Okay, so the frequency heard by an observer is the speed of the wave plus the speed of the observer over the speed of the wave plus the speed of the source times the actual source frequency. And so in this case, our observer is not moving. As the train approaches us, then our F1 is just going to be 340 meters per second over 340 meters per second minus the speed of the source. So it's approaching us, so we subtract the source speed, as that appears to reduce the speed of the wave. And then as it recedes, it's going to increase the apparent speed of the wave. So it'll be a plus. So now we can figure out the speed of our source by taking our two equations. So if we do 1 divided by 2, then we're going to cancel out the source frequency and be left with this expression. And our frequencies, we can use our frequencies given, so that will be 92 over 79, which equals 1.1646, and so that equals 340 plus Vs over 340 minus Vs. Rearranging this expression and solving for Vs, so we would have 340 plus Vs is equal to, so multiplying this to the other side, 395.9494 minus 1.1646 Vs. So now moving that to the other, so swapping, and so we have Vs on both sides, or on one side, sorry, is equal to 55.949, and these should be in meters per second still. And so then dividing and solving for Vs, V source is 25.85 meters per second. And now we can use any of our equation, either of our equations, to solve for our source frequency. So F1 is 340 over 340 minus this 25.85 times the source frequency, and rearranging this here, so 314.15 meters per second over 340 times our F1, which is 92 hertz, is our source frequency. So our source frequency is 85 hertz. So just running through this through our calculator. So that's the numeric value of the train whistle's frequency. Okay, so looking through this here, so we have, there's our first equation, there's our second equation. We can rearrange to solve for our source speed, which is a little different. I don't know why. 2.164, 55.76, 395.76. I don't know where that comes from. 1.164. Looks like some kind of calculator error. I don't know which side it's on. But regardless, in the end it comes out to be the same, 85 hertz. So, okay. So whatever it is, it apparently worked itself out, or the decimal places just don't matter. 314, yeah, weird. Okay, well, whatever. I guess the decimal places just didn't matter. It must have been some kind of rounding error there or something. So 85 hertz, so that looks good.